Hello students, welcome back. Today we are continuing chapter 9, moving on and starting section 9.3, which will be our last section here, chapter 9. We're going to talk about the parabola. So parabola would be made if you cut a double cone like so. There is a definition here though that you need to know, and the parabola is a set, it's all the points that are equidistant from a given line, and that line here is called the directrix, and a given point. That point right here is called the focus. So you can see that each one of these points, if you draw a line to the focus and then draw a line straight down to the directrix, those two lines are the same length for every one of these points. That length is the same as that length. That length is the same as that length. And then there's this special point right here called the vertex, and that point is also equidistant from the directrix and the focus, and you can see it's exactly halfway in between them. Now basically for a parabola there are kind of two standard forms I should say for the equation of a parabola. If the parabola opens up to the left or right, then you're going to have a y squared part, and it's going to be y minus k squared equals 4p times x minus h. And the vertex is at the point h comma k. All right, and p, we will talk about what that number is in just a little bit. So if it opens to the left or right, then the y minus k is squared, and then over the other side you have 4p times x minus h. If your parabola opens up and down, then you've got x minus h squared over here equals 4p times y minus k. All right, now let's talk about what that letter P stands for. So here are a bunch of parts on this parabola. Let's talk about what they all are. First of all, this point right here is called the vertex. That's the point HK. This point right here is called the focus of the parabola. And then this line right here is called the directrix. All right. And then hopefully you remember that this green line is the line that splits the parabola in half. That is called the axis of symmetry. And on that axis of symmetry will be both the vertex and the focus. Now you can see I've got these lines drawn in here. This distance here between the directrix and the focus is the same distance as the distance between the vertex and the focus. That is called P. So the value of P is this distance right here from the vertex to the focus, which is the same as the vertex to the directrix. Now, if P is positive, like in this one and this one, so it will open either right or up. So like if it opens the x direction, a positive value for P means it opens to the right. If it opens the y direction, positive value means it opens up. If it opens to the left, that's when P is negative. So if this number is negative, that means it opens to the left and the focus is left of the vertex and left of the directrix. And if it opens down, then P is negative and the focus is below the vertex and the directrix. All right, so let's take a look at kind of how this works with the equation. So you can see on Desmos here, I've got this equation like so. Hopefully you know that the values of h and k will move the vertex. H will move the vertex left and right. K will move the vertex up and down, which moves everything up and down. And then this value here for P, right now I've got it set to 1, which means that the vertex is 1 unit away from the focus. So that's the focus right there. There's the vertex, and you can see, yeah, that's a distance of 1, and then it's also a distance of 1 there. If you make P bigger, like a value of about 2, you can see the focus is 2 units away from the vertex, and the directrix is 2 units beneath the vertex, and you can see that the parabola gets wider. So as P gets bigger, you can see they get farther apart, which makes the parabola wider. If P gets smaller, then you can see they get closer together and the parabola gets narrower. If P is negative, that's when it faces down instead of up. All right. So we're going to now look at some examples where we've got to write the equation for a parabola that meets the set of conditions, and then we're going to graph it. So if I tell you a parabola has a focus at 2, 5, and the directrix of x equals 4. So first of all, you would need to think about the graph and plot the focus there at 2, 5, and then plot the directrix. You have to know that x equals 4 is going to be a vertical line. Then the vertex will be halfway in between those two, right there. And then you should also be aware that the parabola opens away from the directrix, so it's going to open to the left. Now, because this graph opens to the left, I know that I'm going to have a y minus k squared part, and then the x minus h is going to be over here with the 4p. But because it's to the left, I know that p is going to be a negative number. All right, so that's how I know it's going to be this version right here with the y minus k squared. Then I look at the vertex that I plotted and I plug that in here. So that is the point 3, 5. That's halfway in between those two things. So I plug in 3 there with x, and a 5 there becomes y minus 5 squared right there. And then the distance from the vertex to the focus, you can see from this diagram, is 1. And because it's going to the left, it's going to be a negative 1. So all I have to do is plug in a negative 1 there. And there's the equation in standard form. Now, to graph this, I had to find some other points, because really at the beginning I only knew this point and I didn't know any other points. So one thing I can do to find another point is just plug in a number. I'm going to plug in y equals 0. So I want to find where this graph is at when y equals 0. So I just plug a number into this. I plug in a 0. I can plug in a 0 here. That's negative 4 times negative 3. Or sorry, I'm plugging in a 0 for y over here. So that's negative 5 squared is 25. I distribute that negative 4. I solve for x. And that's how I got this point of negative 3.25 comma x. Or sorry, negative 3.25 is x when y is 0. So that's that point right there. I can then flip that across this line of symmetry to get another point. And that will tell me how wide to draw the parabola. I can also find this point right here. And basically how this works is you have to know that the definition of a parabola is it's all the points that are equidistant from the focus to the directrix. So if you look at this point, it is both 2 units away from the focus and 2 units away from the directrix. And this point will also be 2 units away from each. So the way you can get that point is from the focus, you could move 2p away, and in this case it's above and below, and that point will also be on the parabola. Alright, let's take a look at another one. So the parabola passes through the point 2, negative 1, has a vertex at negative 7, negative 5, and opens to the right. So I'm going to start by saying, okay, since it opens to the right, that means the y minus k is going to be squared, and then 4p times x minus h. Then I know the vertex, so that goes in h there, k there, and there we are. Now, at this point, I know the vertex, but I don't know anything about the focus or the directrix, so I have no way to find p. So what I'm going to do is I'm going to use the fact that it goes through this point to find p by plugging in this point to the equation. So I know that when x is 2, y is going to be negative 1. So I plug in a 2 for x and a negative 1 for y. And then I have to solve. So that's 4 squared, that's 9, and then 9 times 4 is 36, so 16 is 36p, which means p is 1636, also 4/9. Then I plug that in, and then simplify that by multiplying 4 times 4/9, and there's the equation for this parabola in standard form. All right, next, just a quick going the other way, if you have an equation in standard form, how do you find p? So how would you find p from this one? Well, you need to actually imagine this parentheses with a number out in front here, which would just be the number 1. And then the way you think about p is it's going to be the number that fills in that blank right there. So this is the same as 4 times what? And 4 times 1/4 will be the same as 1. So for this equation right here, p would be equal to 1/4. All right, so let's take a look at if we start with an equation in standard form. X minus 2 squared equals negative 12 times y minus 3. We're going to identify basically everything and graph the parabola. So basically what you need to start with is you're going to need to identify the value of P. You can easily identify the vertex and which way it opens, but to find the focus and the directrix, you need the value of P. So basically this negative 12 you can think of as being made from 4 times something. So 4 times what is negative 12? Basically you just divide this by 4, and that's going to be a negative 3. Okay? And that will tell you that P is negative 3. And then with that, we can identify all the parts. The vertex is at 2, 3. The focus is negative 3 units from there, but you have to make sure you know which direction that it's in. So that's where you look at this equation and you say, okay, because the x part is squared, that means it's going to be up or down. And then because that's a negative number, it's going to be down. So the focus is 3 units beneath the vertex at the point 2, 1. That will mean the directrix is 3 units above the vertex. Since this is a horizontal line, its equation is going to be y equals, and 3 units above the vertex will be at 6. So it'll be y equals 6. So those are all the parts I was asked to identify, the focus, vertex, and the equation of the directrix. And now I need to graph the equation. So I know it's going to go through this vertex and it's going to open down, so it's going to be something like that. But to decide how wide to draw it, I need to find like some other point or know where it goes through. I don't just draw it however wide I want. And my tip will be to go 2 times P units away from the focus. So I'm basically going to find a point that's the same distance away from both of these things. So I'm going to go, let's see, P is negative 3, so I'm going to double that and get negative 6. So I'm going to go 6 units away. 1, 2, 3, 4, 5, 6. 6 units to the right of the focus, and you can see that that point is 6 units away from the focus, and it's 6 units away from the directrix. And there'll be another point 6 units this way. 1, 2, 3, 4, 5, 6. So those 2 points are also going to be on the parabola. And then from there, I know how wide, oh boy, it's hard to draw correctly with this guy. But I think you get it. So I'm going to draw a parabola. That is the worst parabola I've ever seen. So at that point, I draw the parabola through those points that I found. So that's it for today. Let me know if you have any questions. And Mr. Cody out. Make sure you hit that like and subscribe.